People tend to think that drawing in 3D is harder than drawing in 2D, especially when you see a building like this that's completely detailed out. All the trades are in, the ducts, the cable trays, the plumbing piping, and it looks a little overwhelming. How do I draw a sprinkler system in there? And what I want to show you with just a very simple demonstration is that it's no different than drawing in 2D. It's just a matter of the tools that you're working with. So to start off, I brought in a screenshot of an AutoCAD-based sprinkler drawing. So this should look familiar to you if you're using AutoCAD. It's lines, it's circles, it's attributes, kind of the way we've always done things in the past. I'm going to build a similar system here using the tools in AutoSPRINK. First thing I'm going to do is use a covered cell tool. This is kind of it's a bay layout tool. I'm going to define an area, and it's going to use some preset parameters, maximum square footage, maximum distance, minimum distance, to lay out and maximize sprinkler heads and pipe in that area. Now that I've got both bays laid out, I'm going to select the coverage cells. I'm going to turn off these dimensions so I don't have to delete them later after I explode the coverage cells, and then I'll split those cells or explode those cells. Now I've got individual pipes and sprinklers. What I've got here is a structural framing plan. It's line segments and it's labels for beams. But AutoSPRINK will actually read those labels and create those beams for me. So I'm going to select all those labels and line segments. And I'm going to use a tool called Convert Lines to Beams. And like I said, that's going to go in, it's going to read those labels. It's going to know which ones go with which line segments. And it's automatically going to create the beams with the proper dimensions according to those labels. Now that I've got my beams, I want to put them up at elevation. I want to start to build my structure. So first I'm going to put in a column, and I'm going to set the height of that column. In this case, I'm using 28'6", and I'm just going to keep this a flat structure, so I only need 4 columns. I'm going to put them at all 4 corners. So I'll put the first one in, copy it down, and then I'll copy those 2 over to the far side. Once I've got 4 columns, I'm going to use those columns to create a set of roof planes. So I'll select the column, select all X selected, and run automatic roof planes. And you'll see those kind of translucent planes come in. Now I'm going to grab all my beams using a selection filter, and I'm going to elevate those beams to the roof plane. And when I do that, I can offset them, and it's set to 0. You see those beams pop right up to the roof plane. Next, I want to move my branch lines and sprinkler heads using the same tool. So I'm selecting the lines and the sprinklers, and I'm going to use the same elevate to roof plane command, only this time I'm not going right to the plane. Because I've got beams that are about 18 inches deep, I'm going to send everything to 22 inches below the deck. Okay, so now I've got my branch lines and my heads elevated to 22 inches below the deck. Now I'm going to get rid of a couple of layers, or just turn them off actually. I'm going to get rid of my roof plane layer, my column layer. I don't need those right now. And I'm going to turn on the layer that's got all my 3D mechanical, my duct plans. So I'll turn on the ducts, and now I want to look at how does my pipe fit with the duct, right? I'm hoping it lays out pretty well with that steel. I put it beneath all those W18s. So my next move is to run some interference checking. So I'm going to select all of my branch piping. I'm going to right click on one of the pipes, and I'm going to go to the very bottom there and hit interference checking. Now this is going to go through and find any conflict I have with ducts or beams. And I can see as I zoom in here, I've got at least 4 conflicts. I have one with this plenum, and it looks like one of the beams is deeper than the others, so all 3 of those lines have hit that beam. So I'm going to zoom in here, and I'm going to grab that first one. I'm going to right click, and I'm going to hit auto arm around. This tool automatically looks for routes around the obstruction. It sees the obstruction and it looks for it. So as I zoom in here, you can see it's kind of flashing a proposed solution. And I can tell it to go left, go right, go over, go under. In this case, I'm going to go left, and I'm going to hit accept proposed solution. You can see it wraps all the way around, and it puts the fittings in as well. That's all automatic. Now I'm going to grab these next 3, and I'll actually select all 3 of them and go into the same command, right click on the pipe, and hit arm around. And again, I get the same choices. I can tell it go over the beam, which doesn't make any sense. Go under the beam, go left, go around. We're going to obviously go under the beam. And then in this table up top, I can check all three, telling the program, let's just fix all three at once. Hit accept proposed solution, and you can see we automatically arm around all of those obstructions. So now I've eliminated the conflicts, the 4 conflicts that I identified in my interference checking. And now I want to start to draw some mains. So far all I've got is branch piping and some sprinklers. So I'm going to put in up here at the top of the page, put in a primary main. I'm going to use the route pipe tool. So I'm going to choose a diameter, start the route pipe tool, and the route pipe tool automatically sets the elevation of the main relative to the branch lines, in this case 2 feet below. It also automatically draws the riser nipple connections as you draw the main. So when I flip to ISO here, you'll see the riser nipples are already in there, and I'll grab all that piping and clean up intersections, make sure I've got proper outlets and branch lines broken at the tops of riser nipples. Now I'll use a selection filter to grab only pipe, which in this case will be riser nipples and cross main, and I'm going to copy that down to the bottom of the page and put in my floater main. So we'll grid these 5 branch lines. And if I zoom in here, you can see you need to run clean up intersections real quick, make sure those connections are right, and then zoom in, you'll see the outlets and see the proper connections there. Now I'm going to go into my details library, and I'm going to pull out a pre-built riser. There's tons of them in here. They install with AutoSPRINK. This happens to be a big manifold with 4 different risers on it. I'm going to just drop it onto my floor plan there. It's not oriented properly, so I'm going to rotate it. You can see the FDC sticking into the building. I'll rotate that 180 degrees. I'm going to move it 2 feet into the building, and then I'm just going to slide it over a couple feet at a time until I've got it where I think I want it. And since it is a block or a symbol, I'm going to go ahead and split that symbol. And now I've got individual pipes and pipes and fittings instead of a single element. So I'm going to stretch the cross main over, select the cross main and the riser I want to connect it to, and run connect pipes to pipe. And that'll automatically make that connection. And I'll get rid of the little bit of extra cross main there. And now I'm connected. So now I've got a riser, I've got my primary and secondary cross mains. Now I just need some underground, and we'll put a supply in, we'll run a calculation. So I'll go 5 feet underground and then just kind of out into space, and I'll drop a supply element in there. So I'll drop the supply in, we'll look at the properties of that supply real quick. 85, 55, 1200, that's fine for what we're doing. That's just my flow test data. And now I want to put a remote area in. Oh, you know what? I also wanted to put in a head underneath an obstruction. So before I put in a remote area, I'm going to copy this upright head. I just kind of copied it off to the side. You can see it's at the same elevation. And I'm going to hit the flatten command. That takes it to 0. Now I can use that same elevate to roof planes command because a lot of surfaces will act like a roof plane, like this duct. So I just elevated that head to 1 foot below the duct. And now I can use our connect pipes to sprinklers command to automatically drop down and arm over to that sprinkler head underneath an obstruction. So you can see how it automatically drops down and cuts over and picks up that head. Okay, so now I'm ready to do some hydraulics. I'll turn this duct layer off real quick, flip back over to my layers tab, and just to kind of clean it up. And I'm going to go up to my hydraulics drop down menu and pick remote area boundary. Check the properties real quick. Should be set for ordinary hazard group 2, 0.2, 1500. Now this tool just lets me draw a polyline around what I think I want to calculate. So I'm going to make sure I've got at least 46 feet in this first distance, and I'm going to just sketch out what I hope is my remote area. And you can see the node tags automatically pop in. That's because I'm flowing already. We do all our calculations right here. I'm turning off the flow for this head under the obstruction because I don't need it to flow inside this calculation. So I'll double click the boundary. You can see the node tags update. I do want to check the size though, so if I click the boundary of the remote area and look in the bottom right hand corner, I see it's a little too big. I can cut a head out. So I'll just grab the grips and I'm going to slide this around. Again, you'll see the node tags update automatically. Everything we do with hydraulics is real time and live in the model. So as I'm changing the boundary and heads fall in and out of the remote area, they lose nodes or gain nodes as needed. And you can see I'm running a calc right now. So I've got, I can check number of heads flowing, my supply pressure, my demand. My system actually works. And the other tabs here let me look at my graph, my node analysis, my pipe analysis, all the calculation information live on the screen at all times. Now we did grid this thing. It is a gridded system, so I want to auto peak it, or I want to peak it, right? So we do have an automatic peaking function in the program. I'm just looking at dimensions right now because I want to fill that in the properties of the remote area. And then I'll run a command that will automatically find the most demanding spot on these branch lines. We'll peak the system. So I'm looking at distance between lines, distance between heads, and I'm going to fill that in the properties of the remote area right here. Once that's done, I can go back out. I'll right-click on the boundary of the remote area and hit Auto Peak. And like I said, that's going to move that back and forth until it finds the worst case scenario on those branch lines, and it'll leave it there. And of course show the results, one head to the left, one head to the right on the cover sheet of the calc. Okay, so what did we do? We took 2D lines, made it into a 3D structure. We laid out a sprinkler system quickly in a couple of bays. We elevated that to a roof plane. We ran interference checking. We fixed the things that didn't work, connected a main, dropped in a riser, dropped in a supply, ran hydraulic calculations, and we're well on our way to this full-blown three-dimensional model that looks intimidating if you start at the finish line, but hopefully you've seen really not that much different than what you're doing. In fact, easier probably than what you're doing in 2D to try to coordinate things in the real world. Of course, having great software is just one piece of the puzzle, right? Now it's time to talk training, implementation, and the real ROI you can expect for switching to AutoSPRINK. So to discuss any of these items, or if you simply have more questions about the software, please call our business development team at the number on your screen. Thanks.